So, everybody's found your pretest? Here we go. Guys, your phones, you can have your phones on you since our quiz is over, but please don't use your phone. Please don't use your phone. We are now focusing in on pretest, right? Now, the very first problem is not even a trigonometry problem. It's just a little algebra simplification. But this is actually what Kara asked about before the quiz. This is a complex fraction, right? You can do whatever you want with it. I'm going to multiply by the common denominator. And what's the common denominator? So I'm going to multiply everything by xy. So absolutely nothing cancels up here. It's going to be x squared y minus, this is a big fraction line here, minus xy squared. But on the bottom now, things are going to cancel. So that's going to cancel with that, and leave me with y minus x. Everybody okay with that? Now, what do you notice about that numerator? It factors. Remember, you cannot cancel until you factor, so there's no canceling to do here, but I can factor the top. What can I do to the top? Take out an xy, and that leaves me with x minus y. Now you gotta be careful. If these were pluses, there'd be no issue, right? Get rid of them. But since they're minuses, I can still cancel them, but what? A negative. You gotta put a negative in there. Because it's like canceling 4 minus 7 and 7 minus 4. They're the same number, but one of them is negative. So when you cancel those, you gotta put a negative in. So your answer is just negative xy. Okay? All right. Prove. Verify. Only way we get good at these is to practice. Oops. All right. So what's your thought as you look at this problem? We have no thoughts. It's a sad state of affairs, folks. Tell me about cotangent. Cosine over sine. So I'm going to try that and see what happens. Cosine squared over sine squared. Minus cosine squared over 1. When we can't figure out anything else to do, and you were all just staring blankly at me, so I couldn't figure out what else to do, you can always change into sines and cosines. Okay? Now, what do I have at this point? I have a subtraction problem involving fractions. What has to happen when you are subtracting fractions? You need a common denominator. So this one needs a cosine squared. So now I'm going to have cosine squared minus cosine to the 4th all over, oh, what did I multiply by cosine squared for? Guys, I'm in that case. Sine squared, that's my common denominator, right? Sine squared. So I have cosine squared minus cosine squared sine squared all over sine squared. All right. I have the right common denominator now. Notice anything? We can factor something out for sure. You can factor out a cosine squared. What will that leave me with? If I take out a cosine squared, I'm going to be left with 1 minus, oh wait. That makes my heart leap because because 1 minus sine squared is what? Cosine squared. So now I have the original cosine squared times another cosine squared, still all over sine squared. Now keep an eye on what you're trying to end up with. There's a cosine squared, I've got him, right? I've got him. I also need a cotangent squared. Do I have that? Yes, because cosine squared over sine squared is cotangent squared. So what I'm thinking in my head is, I've got my cosine squared times my cosine squared over sine squared, right? Isn't that what I have right here? And that makes cosine squared cotangent squared. Now there was nothing tricky about that, but you had to get started. So if you find yourself stuck, like you were there, change in the sines and cosines, and then do arithmetic, common denominator, factoring. All right, what about the next one? What do you think about this one? Any thought about this problem? Exactly. Change this into sines and cosines. So cosecant is 1 over sine. Secant is 1 over cosine. Well, this is like deja vu. Now I have two fractions. This time they're added. I need a common denominator. I'll try to do it right. I need a sine and a cosine, right? So this one needs a cosine. This one needs a sine. So now they both have the same denominator. And the numerator is cosine plus sine. I think we're done. That's our answer. Nothing to be frightened of. One more. You better already be writing down what you're doing here. What are you doing with this guy? Changing them into, so tangent, sine over cosine, that's on your sheet. You should know that already, but it's on your sheet. Secant is 1 over cosine. They already have a common denominator. Oh, wait a minute. Things were going so well. They were. We had one of these the other day. I think it was in our notes, maybe, or maybe it was a homework. I can't remember. What did we do with it? We didn't add something. We multiplied something. Yeah. We put something in the problem. And to figure out what to put in the problem, we looked over here at what we were trying to end up with. And since I want to end up with a cosine in the numerator, I'm going to go ahead and multiply the top and bottom of this by cosine. Now, two reasons for that. First of all, kids, at this point right here, this is where I was, there's really nothing else that I can do. There's no simplifying to do. I can't change sines and cosines into other things. So I'm stuck here. I'm stuck. So I need something to do. So I look over here and say, well, I don't know, I'm supposed to end up with a cosine on the top, so I'm going to put one up there. Perfectly legal, as long as you also put it in the bottom. Now, on the top, I'm not even going to distribute this, I'm just going to leave it alone. But now on the bottom, I have cosine squared. Now, keeping an eye on what's on the bottom of my answer, the bottom of my answer has sines. This is cosine squared. What do I know about cosine squared? 1 minus sine squared.
Yeah.
So now I have cosine, sine plus 1, over 1 minus sine squared. And what about 1 minus sine squared? Over and over again, that can be factored.
Yep.
Because it's the difference of squares. So now I have my cosine sine plus 1 over 1 minus sine, 1 plus sine. There we go. Now, these two cancel with no negative. You understand that? This is a plus problem. Pluses can go in either order. If that were a minus, I'd have to put a -1 factor in, like we did in that earlier problem. All right, that's a tricky one. We okay? Yeah? All right, number 3 is a solve. And it says 0 to 2 pi. So here we go. That means radians. We solve it in radians. I didn't see this problem before. Tell me, what do you want to do? You're all in your post-lunch stupor. All right, what do you think? Drew, you had your hand up for a moment. Want to do something with this problem?
We have to do like the one we did in place.
No. What I want, I need to use my reference sheet though. What's sine 2x? You can't do the problem if one angle is a 2x and one angle is a plane x. They have to all be the same. So what do we know about sine 2x? It's on your sheet. It's 2 sine cosine. So step 1, if you have a 2x in your problem, you want to get rid of that so that it's all x's now. All right, now what? I know we've done this before. Now what? So we're going to subtract cosine over. Remember, we don't divide. Some of you might be thinking about dividing. You can't divide, but you could subtract it over so that you can do what? Factor it out. Now there's a cosine in both pieces, so we'll pull it out. And what will I have left in my parentheses? 2 sine minus 1. Now what do I do after I get a factor? Set it equal to 0, so cosine equals 0. And if I do a little work here, sine equals 1/2. Is that all right with everybody? Everybody get that? Now, zeros are on the circle, so I'm going to have to look at my circle and figure out where the cosine is which letter? X. Where is x? 0. Top and bottom. So what angles are those? 90 and 270, but I'm in radians, so I'll say half pi and 3 pi over 2. That's right, that's 90 and 270. And if you ever just can't get the radians, you know the degrees, but you can't get the radians, then write the degrees down. Okay, because at least you'll have an angle down there. But there they are. Now where is the sine 1/2? Well, start with which quadrants is the sine a positive 1/2? 1 and 2. because sine is y, positive y's are up here. Opposite over hypotenuse, 1/2. How big is that reference angle? 30, which in radians is 1/6 of pi, because 30 is 1/6 of 180. So one of our answers is pi/6. If you're in quadrant 1, that is the answer. What about this one? Now pay attention, it's in quadrant 2, so it will be pi minus pi/6. So 1 minus 1/6. 1 minus 1/6. 5/6. And there are the answers to the question. Okay, we're gonna do one more. All right, here we go. Next problem. This is going to be a calculator problem. So you're gonna need your calculator. And our calculator is going to be set in degrees, because these directions say 0 to 360. Okay? So our calculator's set in degrees. Yep. Here we go. What do you want to do with this problem? Factor it. Absolutely. Kids, isn't it a quadratic? How's it going to factor? Let's see. Tangent and tangent. And plus and minus. Tangent times tangent is tangent squared. I need a -5 on the end, so I'm going to have to multiply a positive times a negative. What numbers am I going to put there? -5, +1. I'm thinking the same way I did in freshman algebra. I need the outsides and the insides to add up to -4. -5, +1. Yep, there it is. So tangent equals -1. That one I can actually do without a calculator, so I will. Or tangent equals 5. I need a calculator on that one. Okay? So where is the tangent negative? Two and 4, Kamara says. Is she right? Yes, she is exactly right, because tangent is opposite over adjacent. Opposite over adjacent. Won't it be negative in those two quadrants? And since it is a 1, I know this angle is 45. Okay. So what are my answers to that part of the problem? What is x going to equal? 135, I heard somebody say it. And how did we get 135? 180 minus 45. And then the other angle all the way around will be 315, because it is 360 minus 45. This one, I'm going to use my calculator, but I need to draw it first. Where is the tangent positive? The other two places, yeah, 1 and 3. Opposite over adjacent, positive over positive, negative over negative. That's where the tangent's positive. 5 and 1 are not my special things. So I'll go to my calculator, and what will I press? What buttons? Second, tangent, 5. And I got 78.69. So what are the answers to that part of the problem? Here are the first two. One of them, 78.69. 180 plus that, which would be 258.69. And there are the four answers to that problem. All right, everybody understand why I needed a calculator? Yeah, because 5 is not special. Okay, all right, well, I'm gonna stop there. We will pick up here tomorrow. We'll also get our quizzes back tomorrow.